Okay, guys, I'm back, and this time I'm going to talk about mass wasting, which is, as we'll learn, basically the process of movement of sediment and surface material downslope for a variety of reasons. So let me share my screen here, and we'll start from the beginning. Mass wasting. Okay, so mass wasting, as I just indicated, is a broad category that includes a lot of different kinds of processes, but what they all have in common is that they're a downslope transport of surface material, so like soil, maybe soil mixed with water, maybe rock, and they're being moved downhill not necessarily by some external force. It's not like a river is carrying them downhill, but they're moving downhill because of gravity. So just the force of the mass in the material or the gravity is acting on the mass in the material and pulling it down towards kind of the bottom place on the landscape and ultimately towards kind of the core of the earth, the densest, most massive part of earth. So you are probably familiar with terms like a landslide, right, which is a type of mass wasting, a movement of a bunch of surface soil, maybe carrying homes or other materials with it down the slope. That's an example of mass wasting, but as we'll talk about, there's other examples that you might not have thought as much about as well. So depending on the kind of conditions of the environment, you may be pretty vulnerable to experience mass wasting where you are, or you might be not very vulnerable to experience mass wasting. So first of all, I'm going to give you a minute to think about what are some factors that might reduce your risk for experiencing some sort of landslide. You can pause the video if you want some more time. Okay, so that was just a moment, but again, remember, you can always pause the video if you want more time. But factors that reduce would be things like if you're on a flat ground, right? If you're in a valley bottom, you're not likely to be on a landslide. You could have a landslide land on top of you, but you're not likely to move downhill. Other examples would be areas where there's good friction. So that might happen in drier soils or different types of material that are just going to kind of push against each other and not be as more effectively and not be as slippery. And then certain kinds of rocks, kind of due to their inherent structure and the inherent structure of the minerals inside them, might just be stronger and less likely to kind of have some breaking that would kind of have layers on the surface slip off. So those would make you less likely to be in a landslide. On the other hand, if you are in areas that are steeper, you're much more likely to experience this mass wasting. And then also, if you're wet, water, we discussed in the context of earthquakes and liquefaction, is a very effective lubricant. When you put water molecules in between rocks and soil, it makes them much more slippery. Okay, so if you have lots of water, then first of all, the land itself is going to be heavier, so there's more mass to pull on. Okay, like wet things are heavier than dry things because there's extra water weight in there. So that is extra mass, but also now the particles are going to be slippery, they're sliding around, so the friction is reduced, and so you're more likely to slide downhill in wet conditions, like when it's been raining, than in dry conditions. Okay, so what are the kinds of things that are moving in a mass wasting event? Well, the first one is just soil. So you can just have different grains of soil or what you might think of as dirt. So this isn't going to be big materials like boulders, but this is going to be like sand, silt, or clay-sized materials, maybe with some gravel mixed in. Earth is another word that sometimes people use to talk about mass wasting, so movement of some earth. And when they use this term, what they usually mean is that there's a big slab, a big chunk of the surface that is kind of moving all together. So instead of just having a bunch of soil grains or rock like tumbling downhill and mixing around as they go, instead you're kind of taking a big thick slice and then you're moving that slice all together downslope to a different position. So sometimes when that happens, we refer to the piece that moved as some earth. Then sometimes you'll hear about debris flow. So this picture on the right is showing a debris flow. And this happens when we have a mixture of different kinds of material. So some soil with rock, soil particles of different sizes, rock cells of different particles, maybe some water too. And also it's like taking trees and logs. In a terrible scenario, could be picking up houses and cars. And moving this material all together. So it's just like a big mix of all different kinds of debris that are moving down the slope. And then finally, mud flows are when we have soil that has become completely saturated with water. So in this case, soil that we've talked about already is completely filled with water. So all those spaces in between the soil solids are completely filled with water. There's no air in there. That's what saturated soil means. And we call saturated soil mud. So if we have a mud flow, then we have not just some water mixed in with soil and rocks, but a really saturated kind of slurry of soil particles. Okay, so again, things like landslides are probably the first thing that comes to mind when we start to think about landslides. But a lot of mass wasting, this movement of material downslope, is much more or much less dramatic than a landslide. And these kinds of events are referred to as slow mass wasting events. So not these dramatic, notable events that we can really visually see, but there is a lot of movement of soil and rock downslope that occurs slowly over periods of time, but adds up to large amounts of soil movement. So this is more likely to occur on kind of rounded hill slopes, so areas where there is a slope, but it's not a super steep slope. And so there's two kind of categories of these slow mass wasting processes. The first one is called soil creep. And basically this is just like the very slow day by day, soil grain by soil grain, slow movement that happens as soils shift around with wind, with plants, with raindrops, with animals walking by, and then maybe they were sitting originally in a position where they are quite stable, and as they get bumped a little bit, all of a sudden the friction that they had that was pushing on them from nearby soil particles isn't enough to hold them in place, and they start to roll down until they kind of come to another stopping place. And this is visually imperceptible, like you can't sit there and watch the ground and then observe soil creep in real time, because it's happening on a much more kind of like microscopic level. But it is happening on the surface all the time, every hour, every day, and over geologic time, it can add up to a lot of work. I mentioned like animals, raindrops, plants, wind, but another thing that can happen is freezing and thawing. So if we have water that's kind of gone down into the soil and then that water freezes, it expands and it can push soil particles upwards, and then as it thaws, it contracts, and so that kind of heaving of the soil can cause soil particles to kind of be loosened, and then they can roll down the slope. Okay, so that's soil creep. And then the second category on the slide is solifluction, it's called. And this happens in saturated soil, so soils where all the soil pore spaces are filled with water. And basically this happens because, as we already said, when the soil is filled with water, the soil is heavier, it has more mass than when it's dry, because water weighs more than air. And so the weight of the soil kind of starts to slide down the hill, but the water also makes the soil kind of sticky a little bit. It's slippery but sticky, kind of a confusing concept. And as a result, we get these kind of like lobes of soil that kind of slump down the hill together. So you see this image of these solifluction lobes. Anyway, so this is another process that is kind of similar to a soil creep, but again, kind of in these saturated soil conditions. So these are not dramatic processes, right? Not a landslide, not an avalanche, anything like that, but still a movement that over geologic time can add up to a lot of change on the landscape. Okay, on the other hand, we have fast mass wasting events. And so in this case, we'll have a mass of soil that moves in a very noticeable way. So if you're standing there, you will clearly observe the movement of the landscape. And so all the material might move very quickly in a matter of seconds or minutes. And sometimes it can play out as kind of a slower disaster where it's kind of starts sliding and then slides a little bit more and a little bit more, kind of maybe more over days. But certainly, again, something that is like a visually obvious process to some sort of onlooker. And when we look at where the mass wasting has taken place, we can usually also clearly see the upslope scar, the place on the landscape that used to contain that soil and then maybe had a lot of vegetation over that soil. Doesn't always have to have vegetation, but that's common. And then the area downslope where we have this kind of debris pile of all this material that moved. So in this picture, we have this kind of scar where we can see there used to be a bunch of material on this landscape, right? All the other areas are covered with trees. These areas that are now just exposed dirt used to be covered with trees, and then they experienced a big slide. And so now we see the scar, and then the debris pile is not really obvious in this particular picture. Okay, so there's some different categories of fast mass wasting. They talk about them in your book, so we'll go through them. And the first one that it mentions is a rock fall. So in this case, we have just like fragments of rock that are falling down freely through the air. They can fall individually, like one by one, kind of just fragments of weathered rock that are falling off some sort of cliff or some sort of rock outcrop. And again, this might be like wind or water or an animal or just slow chemical reactions that are happening that are weathering the rock that cause the force that was holding that rock in place to no longer be strong enough to combat the force of gravity. So the force of gravity wins out and the mass pulls the rock downhill. Of course, something like an earthquake would be something that would really jolt this process into kind of high gear. So if you had a bunch of pieces that were just kind of teetering, that were very close to being kind of at their breaking point, and then all of a sudden they start shaking and rumbling around, that force would be enough to cause maybe a bunch of rocks to fall all at once. So what we see in this case is that kind of downslope above the kind of scar where the rocks have been removed, we'll have a debris pile of rock that's sometimes referred to as a talus slope or scree slope. And certainly people who have been walking around in the mountains in the Sierra and in Plumas County have probably seen these kinds of kind of rock fields before, and they are very close to the source of where this material came from, which is some sort of rock outcrop that would be right above the talus below. So in a rock slide, we have not just like a couple rocks moving at once, but like a whole bunch of rocky material sliding down the slope. Okay, so the fragments move together en masse. And again, anyone who's been spending time in Plumas County has probably seen this kind of thing as well. Highway 70 is not unfamiliar with rock slides. We have all these big rock outcrops in the canyon there. And as rock loosens over time, and then maybe like with the help of a lot of rain or wind or freezing and thawing rock, we might get a whole bunch of rock that would slide onto the road at once. Okay, so then another category is an avalanche. And so people often associate avalanches with the movement of snow, but in fact, an avalanche does not exclusively have to be snow. It can be also like rock or other debris. But in this case, it's a mass movement where the pieces that are moving are broken down into very small sediments. Okay, so we're not moving like big chunks of rock or boulder, very kind of powdery pieces. And then they're tumbled with air, kind of as opposed to water. So the solid pieces are surrounded by a bunch of air. And this air filled fine kind of powdery mixture of snow or of rock or of both can move down the slope at very fast speed. So we've clocked avalanches moving like 60 miles an hour. And there'll be just, again, some sort of instability on the slope where this material was originally positioned. And, you know, some small thing just at the wrong moment, maybe it's a skier or snowboarder coming by at the wrong moment, or you know, maybe it's the something that was frozen thawing out just enough, an animal, something disturbs the slope, and so that all of a sudden the friction that was holding this material in place is kind of disturbed. The contact between two things that were sticking together is disturbed, and then the mass of the material is then enough for gravity to pull it down the slope, as another one of these mass movement events. So again, avalanches are commonly associated with snow. We have some avalanches in the mountains here every year, and unfortunately sometimes people die, but sometimes avalanches can be kind of more of a rocky material as well. So the picture on the left is showing more of like what a rock avalanche would look like. Okay, so now we have a slump, which is of course not a very creative name. But this is what happens when we have material that moves as a cohesive unit. So not a bunch of rock or a bunch of tiny pieces of rock or snow tumbling down and mixing as they go, but instead this kind of slice of earth, as we mentioned, moving with kind of continuous contact with the land. So when people talk about a landslide, this is kind of most commonly what they're referring to, these big slumps that happen. And in this case, usually the bottom layer that was originally kind of experiencing enough friction with the upslope scar to hold it in place, stays in contact with the soil below, but it just starts to move. It literally starts to slide like a person on a slide. The person stays intact, but then your back or your bottom moves down the slide. And so this is what happens with these big slides of earth. And usually this happens when there's water that's getting into the soil that's, again, increasing the weight, right? So making it harder for the earth to hold up this piece of land because it's getting heavier. Also increasing lubrication between particles, so making them more slippery. Okay, and then we would see this kind of slump of material. So here's a picture in Southern California of what kind of a landslide might look like, where we have a steep slope right adjacent to a neighborhood. Okay, then we have another group which has to do with when we have saturated conditions. So the soil is even heavier and even more slippery. And these are sometimes called flows, sometimes called mud flows, sometimes called debris flows, sometimes called mudslides. So you'll have different kind of terms for the same concept. But in this case, we have mixed materials which are not sticking together in a slab of earth like in the landslide, but there's lots of water in them, so that extra weight is causing the sediments to slip downhill, and then they're mixing together and churning around a little bit more like in an avalanche, where there's kind of just more tumbling and mixing. And in this case, the force of all the water and all the material is very likely to start to pick up other kinds of debris, whether that's natural like boulders and trees, or maybe cars and houses that I might encounter along the way. And these can do a whole lot of damage. So this is what a mudslide mud flow or debris flow would look like. Okay, that's the summary about mass wasting.